Hello and welcome to this video podcast. My name is Dan Goldsmith. I'm the Technical Director of Armari. Today I have David McAfee from AMD visiting us. David, can you tell us kind of what you do at AMD on a day-to-day basis?
First off, it's great to be here. Thanks for having me out today.
Thank you for coming.
Absolutely. So at AMD, I'm the general manager of our Ryzen CPU business. So all of our DIY processor in a box, as well as system builders. I manage that business for us on a global scale. And in addition to that, I also have the very exciting responsibility of owning our product management team, which is responsible for helping to define and drive our forward-looking roadmap across both desktop and mobile products. So whether it's Ryzen or Ryzen Threadripper or Ryzen Mobile, in one form or another, I get to get my hands dirty with that and play with the future of what Ryzen computing has to offer.
Fantastic. So we're super excited that you came to see us. I mean, can I ask, obviously we don't often get a VP of the Ryzen, head of AMD's Ryzen platform coming to see us. So,
well, I'll say a couple of things. First, I think I find it incredibly important and incredibly insightful to come and talk to our customers to understand what challenges you're facing, how we can help you grow, and how we can get stronger together. The second part is Armari is a very special company. When you look in the world at companies that are building the type of high-performance computing systems for professionals and enthusiasts, there's very few companies like this that exist anywhere on the planet. The amount of engineering that you do to make sure that each of our systems, our Ryzen, our Threadripper systems, get the absolute maximum performance with the best cooling and the best design chassis. Like I said, there are a few other companies that have the ability to put that type of engineering investment into building great systems. And so I wanted to see firsthand what you guys are building here.
Okay.
It was an amazing tour of your labs downstairs and your capabilities downstairs. And I'm really excited to see what you guys are able to do with these next generation Threadripper platforms.
Well, thank you very much.
Absolutely.
Thank you. So one of the questions I had is that obviously we're super excited that Threadripper has come back to the high-end desktop platform, because after the 3000 series kind of went away, we thought the direction was probably more pro-focused. And so when we started testing the new Threadrippers, we were super excited by the performance. But the thing that really struck home was just at the price points that these are now coming in at, it's really brought the cost of Threadripper right back down to the 3000 era. And I think I did a comparison between the cost of the 24 core, which is particularly good value. So adjusted for inflation, when the 24 core came out in, I think, 2019, was it? Something like that?
That's about right.
To the new one, actually it hasn't gone up at all.
Yeah.
So I went and checked the inflation rate on the Bank of England website. This is in the UK. And I said, hang on a minute, this 24 core is the same price now. Because that is the thing that shocked me, was just how much cheaper it is now to get onto a Threadripper platform. Was that kind of a deliberate decision to kind of really bring the price down?
Yeah, absolutely. And I'm very glad that you saw that. That was a deliberate step that we took where, when we made the decision to withdraw from the high-end desktop market, it was driven by, so many of the constraints that existed during the COVID era and the semiconductor supply chain. But really, I think the unintended consequence of that is it changed the dynamic of that Threadripper market entirely. The motherboards got incredibly more expensive. The processors were more expensive. It put building a Threadripper system out of reach for many enthusiasts or freelancers or DIYers who wanted the capabilities that class of platform has to offer. And I think as we went around and talked to partners about what needed to happen in that next generation Threadripper system, what we heard time and time again was as high-end desktop moved out of the market, they saw two things. One was the inflation in the entry price of system to get into that part of the market. And then two was, if you want that high-end desktop board, one of the great things about it is it's a smaller form factor. It fits in a standard size chassis. It doesn't require a monster chassis that doesn't really slide well underneath a desk. And so for many designers, what they really looked for was something that offered a processor, single GPU, a couple of NVMe drives, and 4 channels of memory, and that was perfect for the types of workloads that they were running. And so that was really something that we aimed to do in this generation, was get the cost of entry back down to where we enable a broader part of the market, but then also address those form factor constraints and target in 2 different spaces. For the true workstation professional who needs the absolute most in memory capacity, memory bandwidth, that's the 8-channel platform. PCI lanes, for that matter, just so much expandability and capability in that platform versus the high-end desktop platform, which in our mind really targets that more developer, designer, freelancer who has a very specific configuration that they're building for, maybe has a tighter budget that they're aiming for as well. And we wanted to be able to go hit both of those spaces as we brought next-gen Threadripper to market, or 7000 series Threadripper.
Another question I had for you is, we've seen some very good single or low thread count performance increase this generation. So historically, Threadrippers were fantastic at multi-core workloads, but when it came to game engine stuff, with Unreal Engine being such an important application, having a processor that's good at game engine workloads, so very good single threaded performance or low thread count performance is important. And we've seen with this new Threadripper 7000 high-end desktops that they're really hitting some good frequencies. In some cases over 5.3, and I guess that's maybe luck with the different processors, but so yeah, we've seen some CPUs hitting 5.6 gigahertz, which is very, very close to desktop frequency. So you're getting, not only you're getting desktop performance for the applications that need only a few threads like CAD or Unreal Engine, something like that, and for the other end, so you're getting the best of both worlds, and that was a surprise. Is that this 5.6, this going above 5, that's expected behavior?
I think maybe just to talk about that a little bit, it's no secret that the core chiplets that are a part of the 7000 series Threadripper are the same core chiplets that are used in our 7000 series Ryzen desktop processors. And certainly, as we saw from 5000 series to 7000 series in the Ryzen family, just how much frequency headroom there is generation on generation from Zen 3 to Zen 4. And I think what you're seeing is 2 things. One, in the Threadripper space, we want to make sure that we're delivering very reliable, deterministic performance for professionals who are using these systems in a non-overclocked scenario. Just stock performance out of the box should be absolutely hitting those frequencies across a wide range of workloads. But I think it's also very true that many users will find that in an overclocked mode, in a PBO mode, the ability to achieve much greater than the stock frequency that's on the box, because it shares that same die source with the desktop processor. So I think the phenomenon that you're noticing is right on target and very similar with what I would expect many users to see.
Yeah. So yeah, you mentioned PBO. That's something that we're in the middle of testing. I've just started testing now. We're very excited. PBO has historically we've launched workstations with a focus on PBO. So particularly as the number of CCDs increases, obviously we see the temperature of the chip go down, and it's surprising that you can actually run PBO on some fairly moderate, 360 AIO. Obviously, it's better to use one that's got a full coverage water block, but historically, you could do PBO and get a reasonable performance boost just by using a good AIO, which is great to see. So as I say, we're going to do a video just all about PBO tuning for regular use workstation users. So in the next few days, so we've only just started.
I can say that the AMD overclocking team, when we went to Taiwan and worked with all of our motherboard partners on really the fine-tuning of all the overclocking capabilities of the 7000 series Threadripper parts, they came back incredibly excited. I think every night I would get pictures of, we broke this world record, and we broke this world record, and it was just one after another, and every day that they were there, the numbers just kept getting higher and higher. So whether it's PBO or memory overclocking or just straight up CPU overclocking on air, on liquid, or on LN2, it is absolutely an amazing processor that has a lot of headroom for additional performance through overclocking.
Yeah. I mean, certainly one thing that we've found always with the Threadripper, the thing that we like the most about PBO is that it's completely stable, right? So you turn it on, the processor gets more power, but the processor is in control of the voltage, it's in control of the frequency. If you just use PBO, you just get faster performance, but you never lose stability. And that's the most exciting thing about it, because historically with overclocking, you were always, you might get one CPU to work on one machine and you went to do another machine and that wouldn't quite do it. With PBO, you just go on, turn it on, and set how much power you want to give the processor, and then you get a certain increase in performance. And that's the thing I love the most about it.
I'm thinking as you're talking here, we need to hire you as a consultant for our marketing team to help us tell the story of PBO and what it does for the user. I absolutely love hearing that story.
Yeah, it's what you want. You just want a one button.
Absolutely.
Press the button, I want more performance. Everything's stable. It's great. Yeah. One of the things that you mentioned about 4-channel memory, so during the testing that we've been doing over the last few weeks is, our initial concern is going from 8 channels now to 4 channels, was it going to impact stuff? But we've been pleasantly surprised that the 4-channel DDR5 is about on par with 8-channel DDR4. And I think a lot of people probably won't appreciate that memory bandwidth is very close. We've got a video that's going up on YouTube today where we actually went through a ton of testing of 8 different platforms. And that was one of the things that we saw. So that was kind of great news to see that. So that's obviously we're really looking forward to WX90 because we're expecting over 300 gigabytes.
It's going to be impressive. Absolutely. That is really an amazing platform. I think the other thing too is when you talk about the types of workloads that people run on Threadripper platforms, it is a wide range, and it's not. Threadripper is not necessarily a general purpose tool. In many cases, it's deployed for a very specific workload or workflow that has certain characteristics to it. There are some workloads that respond really well to more memory bandwidth and more memory capacity. There's some that care less about that. And so I think, again, it's kind of now we have multiple tools to go attack that space. And depending on what you're running and what workflows you're using day in and day out, you can find the right tool to really be most optimized for that particular job.
Yeah. No, I agree. I mean, certainly the benchmarks are running like the media and entertainment workloads. There's very little benefit from having lots of memory bandwidth. You need some memory bandwidth, but it doesn't make much of a difference at all. The WX90 is going to be interesting, I think, for the AI, computational fluid dynamics, more engineering focused workloads are going to get a big benefit from that.
I think you're right. And I think that's one of the areas where we've seen maybe the most growth and the most interest as we've started talking about 7000 series Threadripper is around, using that platform as the perfect vehicle for AI development with, high core count and high frequency Zen 4 processor cores, or the expandability to attach multiple GPUs to that system. Whether you're doing, GPU compute or CPU AI compute, whether it's training or fine tuning or local inference, it really has the capability to be kind of the Swiss Army knife for whatever you're doing as an AI developer. And I think that's going to be really a very important workload for this platform as we go forward in time.
So right now, there's been 4 motherboards announced. We've got the Asus, ASRock, Gigabyte, and Supermicro. I don't think the Supermicro board's out. I've not seen the Gigabyte yet, but they all have got 4 DIMM sockets only. Now, going back to X399 and TRX40, we had unbuffered RAM, which was not great for Threadripper. Threadripper is fantastic, but all our customers were coming to us and say, we want like the maximum RAM all the time. So now we've got ECC registered, which is brilliant, right? We've always wanted registered memory on Threadripper so that we can fully populate all the memory channels. But now we've got 4 memory channels. So what was the decision? Have you got insight as to what memory modules are coming? Are we going to get affordable 128 and 256 gig memory modules? Because that was our kind of concern about what was the decision to go with 4 memory channels? And,
there were a few things you mentioned in there. So first I'll say, I think one of the one of the harder choices we had to make in this generation of Threadripper was UDIMM versus RDIMM. And in DDR4, that was the same socket, completely compatible. That choice could be made down the road. But in DDR5, different socket, different pin out, and that's a choice that had to be made from the very beginning. And I think you recognizing exactly the same thing that we felt, which was for this class of product, using RDIMM is absolutely the right choice. It gives the stability, the performance, the capacity that users who buy this platform are going to need. Now, the 4 memory channels on the TRX 50 platform boils down to really a couple of things. Number one is, I mentioned earlier about the form factor of the board. We really wanted to ensure that HEDT board was constrained to fit within an ATX footprint. And when you go to 8 memory sockets, I won't call it 8 memory channels, but 8 memory sockets, first and foremost, you almost inevitably break that ATX form factor and push into an eATX size, and then you have lots of complications that go along with that.
Sure.
But I think the second part of it is, just like you see in the 7000 series processors, that drop off in memory speed from 1 DIMM per channel to 2 DIMM per channel with the loading on each channel is pretty dramatic. Yeah. And we wanted to make sure that we maintained very high memory throughput in addition to all of the other attributes that come along with capacity and latency on the platform. And the only way you can really do that is having single DIMM per channel.
Right, okay, that makes total sense. So one other question then, something between again, it's probably to do with cost and complexity of the board, etc. But we have this situation where the Threadripper Pro's got 128 lanes PCI Gen 5. The high-end desktop has got, I think it's 48 lanes. So the motherboards have got this situation where you've got, particularly on the ASRock and the Asus board, you've got 3 slots which are Gen 5, and you've got 2 slots which are Gen 4. Now, historically, Gen 4 would always come from the chipset, but it's not in this case. They all come from the processor. Yes. What was is that really to keep the cost of the motherboards more affordable?
Absolutely. That's absolutely right. I think as we've built more and more boards that support PCI Gen 5 speeds, what that drives in terms of either exotic materials in the dielectric for the board itself, as well as redrivers and retimers that are required to maintain the signal integrity throughout the board, we wanted to make sure that not only were we keeping that high-end desktop board to the right form factor, but also keeping that high-end desktop board in a BOM cost configuration that supported a very reasonably priced board for the end user. Because we wanted to make sure, again, back to the original spirit of the high-end desktop board, it isn't necessarily aimed at the ultimate configuration. It's aimed at somebody who wants all that processing power and capability. And again, you still have the ability to support 1 or 2 by 16 graphics cards on Gen 5 interfaces in that configuration of the high-end desktop board. That plus NVMe drives, 2 or 4 NVMe still keeps you within that 48 lanes of Gen 5. And we felt like that was the right balance to keep board costs down, yet the right capability still there.
Yeah, I mean, that's one area actually that we were quite surprised at the price point. We thought the TRX 50 boards, it's got PCI Gen 5, it's a Threadripper Pro board. We're seeing workstation desktop boards in the UK around about £500. So we were thinking that Threadripper high-end desktop was going to come in at close to £1,000, but it's not. It's a couple of £100 more than a workstation desktop, which is a big saving compared to where the WX80 boards are now. Yes. So again, that was a welcome thing. I think that was the right choice to.
I'll give a shout out to our motherboard ODM partners who, on the high-end desktop boards, did an amazing job of really kind of hitting the form factor that we wanted to enable and the price points we wanted to enable to make sure that there's that range of solutions out there for somebody who's building a Threadripper system.
Yeah, I mean, Asus's board in particular. 36-phase CPU VRM. The last time we saw that, they did the board called the ROG Dominus, which was Intel's W3175X, and those motherboards were £1,500. And I think that had some like a 32-phase VRM, and we saw the Asus one's got 36-phase VRM, and it's like half the price. It's less than half the price of the ROG Dominus. So that was, yeah, so we're pretty happy.
That's awesome.
Pretty happy about the price point it's coming in at. So obviously we had a bit of a break in the high-end desktop. So we had X399, TRX 40, and then we had this kind of gap of 2 years. And we understand that was chip shortage issues and the explosion of Epic in the data center, all that stuff. We've got high-end desktop back. Is it going to stay back? Is AMD going to try and support this ecosystem? Because we've now got stable. I think the problem we had with the earlier ones obviously was things like PCI Express changes.
Sure.
So there's change from
Sure.
Gen 3 to Gen 4. So obviously there was a change in platform. But now we're on PCI Express Gen 5 and DDR5. I'm hoping they will be stable for a few more years.
Knock on wood.
Knock on wood. So I'm hoping that we might get more generations of processors for this socket now, SP6.
I think that we certainly, between the experience AM4 to AM5, as well as the Threadripper change, it is very disruptive to change the socket infrastructure. And I think one of the reasons that Ryzen has been so successful is the longevity of AM4. I think whether you're talking about AM5 or this new generation of Threadripper platforms, our desire is to keep that socket intact, to keep that motherboard ecosystem intact as long as possible. And truthfully, bringing back high-end desktop, that was a very deliberate decision to re-enter that part of the market. Now, I think the thing that really ultimately will be the test is how the market responds to it. Right. If we see continued demand or growing demand in that high-end desktop space, it's absolutely a piece of the market that we want to continue to support. But I think the market's going to have to speak about whether true pro workstation or the high-end desktop space, whether it's one or the other, or whether it's both solutions that the market really desires.
Okay, fantastic. Thank you.
Sure.
Okay, so I think that kind of wraps up. So again, I know you've got a busy schedule in the UK. I'm sure you've got lots of other customers to go and visit. So thank you again for coming to see us. It's been a great privilege to have someone so senior from AMD come to see what we do, and that's just brilliant. Thank you.
Thanks for having me. I really appreciate the time here and really appreciate what you guys are doing as a partner.
Great, thank you. Thanks everybody. See you in the next video. Goodbye.